gentlemen, a warm greeting to you all. We are delighted to welcome you to the 25th inaugural lecture of the prestigious Inaugural Lecture Series organized by the Faculty of Graduate Studies at the University of Moratuwa. To formally inaugurate today's proceedings, it's with great honor and pleasure that I invite Professor Dassanayake from the University of Moratuwa to introduce our professor for the day, Professor Palitha Dassanayake from the Department of Mechanical Engineering of the Faculty of Engineering at the University of Moratuwa.
Good afternoon, everyone. It is with my great pleasure to introduce our distinguished speaker, Professor Palitha Dassanayake, for this inaugural lecture. Professor Dassanayake graduated from this university in 1991. Upon graduation, he made a pivotal decision to pursue an academic career by joining the Department of Mechanical Engineering as a lecturer in 1992. He extended his education by obtaining his doctoral degree from Osaka University, Japan in 2000. Specializing in artificial intelligence-based control system for intelligent robotics. Upon his return to the Department of Mechanical Engineering, after completing his doctoral degree, Professor Dassanayake embarked on a journey of innovation by developing the control laboratory, focusing on the utilization of programmable logic control systems. Despite limited government funds, he successfully secured financial support from local and international companies, including Siemens in Germany, through various proposals written by himself. Driven by this passion for innovation, he successfully secured financial support from local and international companies, including driven by his passion for innovation, Professor Dassanayake designed and developed his own laboratory experiment model for procuring used machine parts and receiving direct donation from the state and corporate institutions. Under his leadership as the laboratory in charge, he further enhanced the laboratory, obtaining additional funds from the government. Professor Palitha Dassanayake is not only a renowned expert in academia, but also a distinguished engineer whose contribution has significantly impacted the Sri Lankan automation industry. He has spearheaded numerous industrial projects specializing in PLC programming, modification, and the design of automation system for water treatment plant and transmission line, collaborating with experts from various engineering disciplines. With his expertise in the industry, Professor Dassanayake obtained his charter in the Institution of Engineers Sri Lanka in 2010. From 2011 to 2014, he served as the head of the Department of Mechanical Engineering, where his visionary leadership led to significant advancement with the department. During his tenure, he successfully secured funds for establishing new aeronautical and mechatronic engineering streams under the Department of and obtained the ISL Washington Accord accreditation for the mechanical engineering degree program for the first time. Professor Palitha Dassanayake's academic endeavors extend beyond the leadership. He remains actively involved in research and postgraduate education. In recognition of his scholarly contribution, he was honored with a presidential award for scientific publication bestowed by the President of Sri Lanka in 2013. As we eagerly waiting his entrance, let's extend a warm welcome to our esteemed speaker. May his word ignite curiosity, inspire creativity, and pave the way for future enriched by knowledge and enlightenment. Please join me with me in welcoming Professor Palitha Dassanayake to the podium.
Thank you very much, Professor Sari, for that great introduction. Good afternoon to you all. Professor Gopara, Dean, Faculty of Postgraduate Studies, Professor Mandeep Tamarasinghe, that is the Department of Mechanical Engineering. Professor Salia, who just introduced me, Professor Puncheva, and all my colleagues, academics, students, friends, and my family. It is a great pleasure for me to conduct this lecture series, and I am delighted to be here. As Professor Salia mentioned, I did artificial intelligence control of robotics during my PhD. So in my return to Sri Lanka, I started doing mechanical engineering applications with artificial intelligence techniques that led to this topic, artificial intelligence applications in mechanical engineering. So robotics, as I mentioned, I have applied, and after return, I did it with mobile robots, and energy is one other favorite area, and industrial engineering, as well as biomedical engineering. I have been involved in doing research together with this artificial intelligence of computing techniques. So before I proceed, I would like to just mention about this artificial intelligence. It's known as a machine or a computer system that can work or solve problems like human intelligence. So tasks could include finding solutions like humans, understanding natural language, pattern recognition, decision making, and so forth. And these systems can be included or given in various ways, whereas I have given my contribution in intelligent control systems and decision support systems. And you can implement artificial intelligence systems in many ways. So I have placed here 3 ways of implementing. Symbolic AI. As the name implies, symbolic AI means use symbols, logics, or rules to represent and manipulate knowledge. And generally, it is done through explicit programming. And fuzzy rule-based system is one example of symbolic AI. And then Connexious AI, that is inspired by the structure and the functions of human brain. Artificial neural network is one example. Evolutionary AI uses evolutionary algorithms to solve problems while evolving with generations, mimicking the natural selection. So genetic algorithm is one example. And I have taken carefully these examples because I have been involved in using fuzzy artificial neural networks and genetic algorithms. So before I proceed, I believe it is my duty to briefly introduce those techniques. Fuzzy sets and fuzzy logic. So given a statement, there exists a heap of sand. So the question asks is this statement true? So answer is simple. If there is a heap of sand, you simply say yes. It is true. And if there is no heap, you can simply say no. But if I remove just one grain of sand from the heap, is it still a heap? Yes. Just by removing one grain of sand, nothing happens. You can say, yes, there exists a heap of sand. The statement is true. So truthness of the statement remains the same, it does not change. So what happened if we remove another grain from this one and then another grain, and if we bivalently argue this and do this iteratively, we will remove all the grains of the sand and say there exists a heap of sand. Or suddenly it has vanished. So to give a solution for this, we should consider this transition gradually. So if I write the statement like this, after removing 1 gram, 1 minus some very small amount, so you get this 0.999 some value, which is according to this graph. So every time you remove 1 grain, fuzzy value or the truthless value removes. So this gives you the idea that there are infinite number of truthless value between yes and no, or false and the truth. So this idea was first introduced by Professor Zade in 1965. Actually, his paper was rejected many times, and later he managed to publish it. And this is the name of that article: superset of conventional logic that has been extended to handle the concept of partial truth. And even after publishing, there was many criticism about this, saying that this is a crazy idea. His so-called crazy idea began to get appreciated in late 1980s and early 90s when researchers wanted to conduct research on artificial techniques. And this chap beside him was myself, and I was fortunate enough to meet him at a conference in Japan while I was a doctorate student. So even after that, there was some dispute that fuzzy is a disguised version of probability. So to cater for that, to handle that, there was a letter paper, IEEE letter paper, explaining it's just half a column, fuzzy versus probability. So I will use the same example to explain that. Suppose you have a thirsty person. He's thirsty, so he wants to drink water. So he's going to find potable water, and he has two choices. One bottle is 0.9 probable, the other is 0.9 fuzzy. What does this 0.9 probability and 0.9 fuzzy means? So he has to choose only one. 0.9 probable, there are 10 bottles, drinkable, very good drinking water. One is poisonous. So somebody has randomly selected one bottle and place it there. So there is this 10% risk involved. What about 0.9 fuzzy? It means it is not purely good drinking water. It's between this truth, false and truth. So the statement that bottle is potable is 0.9 truth value, which means it is not very good drinking water. But you can drink and you will not die, or you will not even get a disease. It's a higher value. So I would choose the fuzzy bottle. I don't know what about you all. It's a personal choice anyway. So next, we'll go into this artificial neural network, which is inspired by biological neural network. The basic part of biological neural network is the neuron, and this shows this structure of the neuron. You have dendrites where you receive information in the form of chemical particles from other neurons or receptory sensors. And once you get this chemical particle, this neuron has a negative voltage, small negative voltage. I will explain it. And when it passes certain threshold value, due to these chemical molecules, this get a pulse which goes through this axon to the synaptic end bulb, where you have a synaptic chemical connection. So you have chemical molecules at the end bulb which transmit to other neurons through the dendrites. Generally, there are other ways of transmitting as well. So let's see how this works. Neural axon is covered with semi-permeable membrane with only 5 nanometer thickness. And membrane acts as an ion pump. We have extracellular fluid and intracellular fluid. Intracellular fluid has a negative about minus 70 millivolt than extracellular fluid, because this membrane will not allow every ion to move around freely. What happens when soma potential exceed the threshold value? This membrane breaks temporarily, and then ions start to pass very freely, so that you get a pulse, which is known as the action potential. And when you start going very fast, it will go beyond even the zero value, and the membrane gets created again, so it will come back. And this action potential results in electrical current flowing in the region at action potential adjacent region, so you get this propagation signal throughout. And you have actually a frequency of signal. So that is how our neural network works. So one neuron is connected to 1,000 to 10,000 other neurons. So that is how we work, that is how we think. So that is the idea of the biological neural network. I am saying very, very briefly. So which led to artificial neural network. So I will not go to these mechanisms of artificial neural network, but it's nowhere near this biological neural network. It's a very, very simplified version of this. So you cannot expect what you get from artificial neural network from the like in the biological neural network, of course. But it has its own computational power. The other problem is now biological neural networks get trained. The real training algorithm, why it's trained this way and that way, is still a mystery today. So for artificial neural network, we use different kinds of training mechanisms. And it works very well with pattern recognition, noise removal, pattern completion, those things. Work to somewhat for optimization problem. For controls, generally no, although I have used artificial neural network for my work. And I met one professor, Australian but Sri Lankan native, in 2001 at Colombo University. So we talked about this using ANN. I was just after returning, so I was very keen on using them, and he said we have strategically taken a decision not to use artificial neural network for our control systems. The reason could be because it is not that there is no ANN. To find the suitable ANN is very difficult for particular application. It's not very straightforward, standard. And the training method also not very well, and not like pattern recognition, you have the similar types of networks, and if you use similar types, you get the results. Your control systems, mathematical models are different, so you naturally will have to use different types of neural networks. So that's the main problem. Then we'll go to this genetic algorithm. As you know, child compromise of genes of the parents, that's the DNA of the parent, which gives you the eye color, complexion, and so forth. So this idea is used in genetic algorithm by using the genes as the genome code and the variable as a complex code. So I will explain not only the genetic algorithm, but the general evolutionary computation algorithm, general technique. What we really do is you produce random initial generation. Here you have individuals. This one individual is a solution to this problem. It could be a good solution or a bad solution because it's randomly selected. So then we evaluate them, evaluate the whole generation one by applying this into the system. Thereafter we select parents, some better individuals, but some randomness also introduced. Not all the better or the best individuals are selected as parents, but there's a mechanism like in the natural selection. We let only the good parents to mate, and then these parents they produce children, reproduction through some mechanisms, and you get offspring of the children. These offspring could be generally good or worse than the parent, and you have the new generation. From the old generation or the initial generation and the new generation, you select the next generation. And from that, there is already not done like the very best go there, no, we have some randomness included, like in natural condition. And you have this next generation. The same thing repeats again and again, and it is found that when generate the higher number of generation, you get better individuals. So using this problem, the main advantage is you don't have to know how this is getting optimized. No analytics is required. It's a heuristic method. But the disadvantage is that you might not get the optimum solution. But if you can satisfy with a better solution, this is good. So now I will come to the applications of AI. So this is my PhD title, and at this point, I would like to mention my supervisor's name, Prof. Dassanayake, and thank him for guiding me throughout my research career during Japan. So here I have used two manipulators. One is a 3-link manipulator, which travels in a 2D direction. The other is a pneumo manipulator, which is a 6-link manipulator, 6 joints. To start with 3-link manipulator, we did a simulation using dynamics, but all the practical aspects were not included. But for the Puma one, I had to include all the practical aspects, discuss friction and maximum torque saturation. So the simulation was done using programming using Scratch C, in basic C program. And this is the control system that you use. You have 3 behaviors: objective behavior group, free behavior group, and reactive behavior group. All these are fuzzy neural networks. Objective behavior groups try to reach a target. Free behavior group try to explore the environment. Reactive behavior group try to avoid the obstacle. And through this behavioral fusion, which is known as competition or cooperation here, and that information is given to the robot and you get the feedback information. So as mentioned, each behavior group is a fuzzy neural network that was trained by genetic learning. So here also one individual is the solution to the problem. So to evaluate the individual, we have to have a fitness function. In this case, if the individual reach the target, we give a fitness value depending upon the distance traveled and the time taken. And if the individual collide with the obstacle, you give a penalty. That's a negative value. So we managed to get some good results for both manipulators. So after coming back from Japan, I started doing these AI techniques to mobile robots. This left corner one, this one, we call it NeoRobot. We use it for autonomous navigation. Actually, this was done through not through undergraduate here, but an undergraduate of different institute informatics. We use only infrared sensors here, and there's this sensory fusion took place through the sensors, and one sensor only rotating. Not only the actual one, did the simulation as well. And here also we use fuzzy behavior based approach. And then the second one, intelligent behavior sensor fusion for mobile robots. The same robot was used again as a master's project. Here we use two types of sensors, sonar sensors and ultrasonic. And then there's a control. This picture shows the control platform for the mobile robot team to move in a formation of an indoor environment. You have one robot moving and the others are followers. So there are other types of projects that I have done using mobile robots, and they are listed here. And almost all of them have used AI techniques. So then I'll go to a different topic, energy. One problem of energy is when you have more number of energy resources, to select which resource and when. You can have a generator, you can have a solar, wind, battery like that. So this is one master project that I did with energy experts in the department. So multi-criterion decision making based on techno-economical optimization of standalone hybrid energy systems. So this is a standalone system where you have wind turbines, solar panels, battery pack, and internal combustion generator. So the selection criteria is on initial capital cost and life cycle cost, emission, and reliability. If you look at the reliability, good reliability will increase cost as well. We want to decrease the cost while increasing the reliability. There's a contradictory objectives, so you can't just use weightages and come up with one function. So for this multi-objective optimization, you have to select all types of solutions. So there are, when you compare, you look at each objective separately. So it can be a feasible or non-possible, and get the dominant solution, term using comparison with another solution, where at least one objective can be improved without degrading the other one. So this is known as Pareto multi-objective optimization. Selection of better individuals are done using constraint tournaments. Selections of feasible or dominant or non-dominant. So this is the better individual selection method. We use now a little other way around. Normally use the dominant solution, but for our problem, we need some acceptable solution, so we don't want them to degrade. Therefore, we use a little away from the actual practice, and got the feasible and non-dominant solution were given priority over the dominant solution. And any feasible solution is preferred over non-feasible solution. And if both are infeasible, we use this one or two rules or just select. And some conclusions from this work, that the decision depends on the objective use and the size of expansion. So we can't just say you have to use this number, that number. No, it depends on the objective use and the size. And it is recommended to have a gradual integration of renewable energy when you consider in terms of cost. And we managed to give a novel technique that combines fuzzy topsies with Palitha multi-objective optimization in designing standalone energy systems. So we obtained a presidential award for this publication in year 2013 by the President of Sri Lanka. And I have been involved in other research projects in energy. Intelligent light controller is, of course, control is intelligent. This harvesting of kinetic energy of the raindrops is not, we have not used intelligent techniques, but there's a potential to use it. So this intelligent light controller, we try to use the natural lights and the artificial lights and controlling them. So to get a good solution in the Sri Lankan context, so that even the user can change the way he wants. So these are kind of architecture drawn here. To control the natural light, you have the blinds. By rotating lines, you can control the natural light, and by dimming, you can control the artificial light. And in addition to that, there's adaptation algorithm. So when user wishes to change it, that get adapted according to the user. And harvesting of kinetic energy of the raindrop, you can use potential energy and use as hydropower. That's one way. The other way is to get the kinetic energy from the stress and the vibration when the raindrops are dropped onto piezoelectrical devices that are capable of converting this stress and vibration into an electrical energy. Actually, what we did was a numerical simulation on a single drop. So when it comes to multiple drops together, we did for different size drops, but different sizes, but we didn't do for multiple ones. It's too complex, and you have to use AI techniques. And then optimization problem in scheduling is the area of industrial engineering. So I've done two projects in the industrial engineering, both scheduling projects. One is intelligent scheduling of tournaments. The other is new approach to solve dynamic job shop scheduling. So intelligent scheduling of tournaments, this I did a long time back. To overcome the problem of scheduling manually with conflicting factors. Now find it's very time-consuming jobs to schedule a tournament. You have to take many constraints into account. So idea here is to automate. So this evolutionary algorithm was used. That is quite similar to genetic algorithm, which is a heuristic method and quite easy to use. But you don't have to hack your mind to see why it is, how to optimize it. Optimization is done through the algorithm. And when you compare the results with the manual method, automation found to be superior. But there was a small problem with this one. If somebody want to reschedule it, this system does not allow it. But that in scheduling tournaments, that happens in once in a way, not always. Then we had to come up with another one. This is a master's project that I did. Job shop scheduling. Here you can't escape from them because it has to be dynamic in practical situation. Now, to actual industry, jobs can come in while we have already scheduled for the other jobs earlier. So it has to be dynamic. So here it is handled through a new representation of chromosomes. And for this work, we use genetic algorithm, and that works well as well. And biomedical applications I have used with biomedical experts in the department. So in both of these cases, it's prediction. One is the elbow joint torque prediction. There we use ANN based classifier, that is artificial neural network classifier, and artificial neurofuzzy inference system classifier. And the other one is estimation of prosthetic arm motion using some kinematics, there also we use ANN based classifier and fuzzy logic based classifier. So in addition to this mechanical engineering applications, I thought of why not analyze some of these soft computing techniques, and I have analyzed them. The effect of mutation, which I did on use of mutation in genetic effort. That is one analysis I have done, which is published. And is the other analysis. Now you know, Professor they introduced fuzzy sets, and he has given a rule for fuzzy set intersection, which is the minimum rule. But thereafter, researchers have started using product. And if you use these two rules, you get two different results. But most of the cases, sometimes you case for imprecise situations. So, and people are using like there are two rules. I'm using this, and I have analyzed this, and I found that production or the multiplication product rule or the multiplication rule is better. The minimum rule is only an approximation. That was also published. So currently, I've been involved in soft robotics and soft preppers. I have not used AI techniques yet, but there's high potential to use AI techniques. And this soft robotics also a very new emerging field. To look at the difference of hard robots and soft robots, to pick and place an iron bar for a hard robot, it's easy task. But pick and place a fragile thing like a food material, say strawberry, it is difficult. So you need actual at least of papers, and we have tried to use soft manipulators. The problem of soft manipulators is that you don't have a generic mathematical models for soft manipulators, and it's difficult to control. They have developed mathematical models, but only for their case. And in using soft robotics, it does not only depend on the controller, but on the type of the material that is used. So if you are going to use soft robotics, you can't just do it, you have to come up with an application. So I choose different applications and start doing it. And one is here, bio-inspired bone types of robot for bite dissection. And we have started doing this growing and everting robots, of course, with certain applications in mind as well. The growing robots is you have the base stationary while the robot is moving by elongating the body, or simply say growing or extending the body, or retracting the body. It's mainly used for exploration purposes. And these everting robots can be used in air or in underwater. So we have used both. The first one is this one experimental evaluation of steering actual configuration on the behavior of the soft growing robot. So this we have analyzed how to steer it. This is one undergraduate project conducted. This video shows the robots that we did. And this is the underwater project, and it's not very clear. You can see in the upper picture the moving part of the robot. Okay, it's not very clear because the boat and the robot material are both transparent, and so the below picture shows the robot part with the software. Using the software, we have managed to do that, and so the application was given as like exploring the reefs, but there are a long way to go. But it is just the application, because here we use the stationary motor, but in real time it's more different, more complicated. But this is a start. And then food handling. Food handling means you can pluck delicate fruits without damaging the plant or the leaves. for handling of food for automating food handling industry. So we have conducted a soft pneumatic gripper for reducing food damage during strawberry harvesting. So we have come up with a good gripper that does not harm the strawberry. And we have developed a system engineering-based approach for the development of a strawberry harvesting robot. It's just the approach, the concept that we have developed, and the design and the development of the soft gripper system for difficult to handle foods. Both projects are still undergoing. So this is a strawberry harvesting project, the photo of that, and this is a concept that we use. It's a we cannot actually use this in the indoor environment. There are a lot to improve, but we just want to try out with our concept, and the concept was proven. And this robot was very slow, and we have to go into the outside environment. So, with the knowledge of the mobile robots that we did earlier, and coupled with all that, using AI, and we should be able to go further with this one. And for future work, so I thought of going into these two directions, especially inverting robots and food handling with soft grippers, as well as I'm going to start a postgraduate research on autofocusing microscope for blood analysis. So that will give amount of places to use AI actually, because you have to, even autofocusing itself, you might have to use AI, and especially blood sample analysis, blood counting, everything, you need these techniques. So finally, I would like to thank Professor Gopura once again for giving me this opportunity. And I would like to thank you all for participating for this event, and I sincerely hope that you have received something to take home from this inauguration lecture. Thank you.
Thank you, Professor Palitha Dassanayake, for your enlightening session on AI applications in mechanical engineering. Your insights have truly enriched our gathering today. Now, I would like to extend a heartfelt invitation to Professor Ranjit Amarasinghe, the head of the Department of Mechanical Engineering, to present the lecture memento to Professor Palitha Dassanayake. Additionally, I would like to invite Professor Palitha Dassanayake as well to join us on this momentous occasion. Many thanks to both Professor Ranjit Amarasinghe and Professor Palitha Dassanayake. Before we draw today's proceedings to a close, let's take a moment to express our appreciation to the sponsors of today's inaugural lecture. Targets Private Limited, our event sponsor, Daily FT, the print media sponsor, the Sri Lankan Scientist, the social media sponsor. With this, we conclude the 25th inaugural lecture organized by the Faculty of Graduate Studies at the University of Moratuwa. We deeply appreciate your presence today and look forward to welcoming you back to the 26th inaugural lecture, and thank you once again for your participation. Have a wonderful day ahead.